Let's suppose you work for Acme Manufacturing. Remember Acme Manufacturing? That's Wile E. Coyote's favorite manufacturing company. He's always buying stuff from Acme in his efforts to try to catch the Roadrunner. Well, let's suppose you work in the division that makes the anvils that he's always trying to drop on the Roadrunner. Not sure why you want to do that. Would there be much Roadrunner to eat if you had dropped an anvil on it? It seems like mostly what would be left would be what the vultures would be picking at, and not what the coyote might want to eat. But let's suppose you work there in the anvil division of Acme Manufacturing. And when you make 100 units, when you make 100 anvils, the production cost for that run of anvils is $5,000. When you make 200 anvils, the production cost is $8,500. Well, the production manager comes to you and says, you know, it would really be nice. It'd be nice if we had a formula that when we know that next week we're going to make 150 anvils, we could have a projection of what the production cost would be. Or when next month we're supposed to make 250 anvils one week, we would know what the production cost would be, because that would be very important for us to know that. It would help us in terms of budgeting and managing our cash flow. And you think to yourself, well, doesn't it seem logical that the more anvils we make, the higher the cost? In fact, maybe it's a linear relationship. Maybe I could think of these as being ordered pairs, where the X would be the units we're going to make, the anvils we're going to make, and the Y would be what it's going to cost us to make that many anvils. And so in effect what we have is 2 points that are defining a line. And what we want to find, that formula for the boss, is a linear equation in 2 variables. Well, what have we been doing to find the linear equation in 2 variables when we've had points? Isn't the first thing we've done is to find the slope, which is the change of y, which in this case would be the change of cost, over the change of x, which would be the change of units, the change of anvils, which in effect is going to be dollars per anvil when we get done, isn't it? So the slope here is going to be what the cost per anvil is for us. Well, what has the cost done? Going from $5,000 to $8,500, that's a $3,500 change in Y, with a change of 100 anvils, which is a slope of 35. This is dollars per anvil. So the slope says it costs us $35 to make one anvil. And we have our M value for our formula that the boss wants. Now, what have we done before? Haven't we simply taken then one of these points as a solution and put it in for x and y to see what that forces B to be? So let's take that first pair. Put 5,000 in for y. 5,000 is representing our cost. Put 100 in for x. That's representing the units that we are building, how many anvils we're making. And we have our linear equation in one variable that we can solve for b. So 5,000 equals 3,500 plus b. b must be 1,500. So our formula is y equals 35x plus 1,500. And now, whenever we want to project the cost, we simply put in a value for x, because x is representing how many anvils we're going to build, and that'll tell us then what the cost y would be. And this is a practical application of what we've been doing in going from points to the equation. Anytime we have a relationship between two quantities that can be thought of as being linear, straight line in nature, we can come up with a formula for it, as we did here.